Python Timeit module. It is used to measure the execution time of small codes. Okay, if you want to measure the execution time of a code, this module will be suitable, and with the help of this module you can compare different implementations of a code and you can find which one runs faster. So this module can run the code multiple times to reduce the impact of background processes also. So why Timeit is used? With the help of this you can execute the code multiple times automatically. It reduces measurement errors. So in this tutorial I will execute the code and will find the execution time of the code with the help of this Timeit module. Basic syntax is you just import Timeit module and then you pass three parameters. So first one is the statement, which is the code statement to measure setup, code executed once before timing, and number of times the statement runs. Okay, so let's discuss the simple example. So this is the code you can see. Okay, I will run this code on my system. And first of all, import Timeit module, and then this is the code, and then I will pass the code here, and then the number of time this code will be executed, and then I will print the execution time. Okay, so just copy the code. So this is the code. I will copy it and paste it in the VS Code. So here you can see I am importing the Timeit module, and then I am writing the code in the comments, and I am passing the code to this Timeit, and number of time I am specifying, and it will print the execution time. So just run this code. So here you will specify the number of times this code will be executed, and the code is, and for I in range, you can write any code. For I am just scaling the value of I. Okay, for I in range 1000 means 0 to 999. I am just what I am doing, I am just scaling the value of the I, and then I am providing the code to the Timeit module and specifying the number of time it will be executed, and then I am printing the execution time, and you can see the execution time is 0.23 seconds. Okay, if I run the code 1000 times, you can change the code and you can print the execution time. Okay, so very easy. With the help of this Timeit module you can find the execution time of the module. Okay, so now what is next example using setup. Okay, so sometimes functions must be defined before timing. Okay, so with the help of the functions must be defined before timing with the help of setup. Okay, so what I am doing, this is the code. It will print the square of a 10, and then I am providing the setup here, and then I am printing the time. So here I will provide the code is the square 10, and then I am providing the setup equals to setup. So this is the setup, and number of time the code will be executed here I am specifying. You can see in the description the function square is created in setup, and then the statement square 10 is executed 10,000 times. Okay, so just copy the code. So this is the code, copy it, and here is my new code. You can see I have specified the code, and then the setup is the function which I have defined to find the square, okay, and I am executing the code 100,000 times. Okay, so just run this code and you can see it will take this time 0.063 seconds. Okay, and now what I will do, I will compare two codes with the help of Timeit module. So I will compare list versus loop. So which one takes less time? Okay, so here I am finding the sum of numbers from sum of the squares of the number from 0 to 99. So for I in range 100, first of all I will find the square and then I will pass into the sum function. Okay, or you can do this with the help of list, or you can do this with the help of a loop. So I am finding the square of numbers from 0 to 99 and then I am comparing the times. So for time it I am passing the list comprehension and then I am passing the loop, and I will run the code 10,000 times for both. Okay, and then let's find which one takes less time. So what I will do, just copy this code and now in the VS Code I will paste the code. Okay, this is the code which I have already explained, and let's run this. Now you can see the list comprehension takes 0.46 seconds and the loop takes 0.60 seconds. It means the list takes the less time for finding the sum of the number, for finding the sum of square of numbers from 0 to 99. So here you can change the range also. Okay, and you can run the loop, you can run the code as per your choice. I am running the code for 10,000 times. You can change it. Okay, and it will compare the running execution time of both the codes. So time module is very helpful if you want to compare the execution time of two codes. It's very helpful. So using Timeit with functions, very simple. I have already explained. Just define a function, okay, and then pass the function in the Timeit module and execute the code. So here I am executing the code 10,000 times. Okay, and just you can change the value from here, define any function. So here I am defining the function test, which will return the sum of the numbers from 0 to 99. Very easy. A repeat method. So this is again very important. Here the repeat function run the timing multiple times. So it means the code will be tested 3 times. If I specify the value of repeat 3, it means the code will be tested 3 times and the code will run 10,000 times. Okay, and the code is this sum range 100. Okay, so very easy, you can do this. So Timeit.repeat, first of all specify the function and then repeat and then number of times it will be executed. So the repeat function runs the timing multiple times. So practical use cases of Timeit module: performance testing, you can compare the algorithms, code optimization. Okay, so this is the practical example. Here I will compare the sorting methods. Okay, so I will compare the sorting method. So first of all I will define the bubble sort. So this is the code of bubble sort. Here I will just focus on the Timeit module. I will not explain the working of this bubble sort. And this is the insertion sort code. Okay, and now this is the data. I am generating the random numbers, okay, for I in range 100. Okay, so this is the data of random numbers which I am generating. So for that I have imported the random module. Okay, so then I will run the code for bubble sort. I will run 100 times, and then insertion sort I will run 100 times, and then built-in sort, which is built in Python, I will run the code 100 times. So I will run the code for bubble sort, insertion sort, and built-in sort for 100 times, and I will pass the function. Okay, and I am creating a copy of the data because the data will be sorted by the bubble sort. So I will just provided the data, a copy of data in the bubble sort, in the insertion sort, and I will pass the data in the built-in sort. Very easy. So I have just generated random numbers, and then I am passing the data in the function. So bubble sort function, insertion sort function, and the built-in sort. Okay, so you can see the bubble sort is taking the list. Okay, so I have just created a randomly list of numbers, and then I will run the code 100 times. Okay, so just copy the code. So this is the code that I will copy, and I will pass it in the Python code, and you can see, so you can see this is the bubble sort and this is the insertion sort. I have defined the functions for the bubble sort, okay, and then for the insertion sort, and then I am creating the data, and then just I am comparing the times of these: bubble sort time, insertion sort time, and built-in sort time. Just I am passing the function, lambda function bubble sort, and in the bubble sort I am passing the data and running the code 100 times. Okay, so just run this. It will take some time because it will sort the numbers. Okay, so you can see the comparison. Bubble sort takes 0.33, insertion sort takes 0.15, and built-in sort takes 0.009. So it means the built-in sorting function of the Python takes very less time for sorting the numbers. So with the help of Timeit module, you can compare different sorting algorithms, you can compare different codes. So this module is very helpful. Thanks for watching.